I'm Ollie Wright, UP2070883. This is my submission for CT6GAMAI, where I've created an AI capable of walking around and interacting with a museum that's placed dynamically by the player. This module's work was completed in conjunction with the work for RigPer after receiving permission from both module coordinators. The goals of this project were to have dynamic room detection, indexing and referencing, as well as a dynamic NPC AI that was able to interact with a museum created by the player. The final goal was optimization, which is incredibly important to have hundreds, if not thousands of actors on the screen, all processing at one time. Before I can explain the AI, here are a couple of systems that are fundamental to understanding how it works. Players can place artifacts and donation boxes which inherit from a single scriptable object class. When instantiated, these create object instances, which contains the world position as well as the interaction points that the NPCs are able to visit. At a base level, the museum is a grid of cells that contain their occupation and their walls, explained in this graphic here. When a wall is placed, it launches probes either side of it in every cell that it could affect. These are then used within a breadth-first search flood fill algorithm. This algorithm operates within a loop which goes up to a depth count of the maximum amount of cells allowed within a specific room. These rooms are then indexed within the museum. Lastly, NPCs operate off frame, tick, and turn updates. This is mainly for the purposes of optimization, but also streamlines the NPC behavior. These are variable in terms of real time, as the in-game time is variable. While in the Wander Desire, NPCs can perceive objects and other NPCs around them. This is from a series of raycasts which are blocked by walls and pay attention to anything tagged artifact, donation box, or NPC. These are then saved for a specified number of turns within the NPC's memory, and then used within the desire calculations. Seeing the object again will refresh the turn timer, and once this timer has expired, the object is deleted from memory. NPCs work with a desire system, which dictates what they want to do at any given moment. When instantiated, NPCs will always want to enter the museum first, and then after that, they wander once, and then it's up to them. Each turn while wandering, at the end of the turn, an NPC will calculate their desire. When calculating, it will choose a desire out of wandering, visiting something, donating, or leaving. The first three are weighted on curves given by mathematical functions that approximate how desirable something would be. Note that visiting is more likely when the NPC has perceived more artifacts and not visited them yet. The propensity to donate increases proportionally with happiness, which increases in turn when an NPC goes to visit an artifact, and even more if the NPC visits an artifact of its interested type, which is indicated by the color on its visor. Once these three have been calculated, the total amount is then adjusted according to the amount that it desires to leave, which remains constantly increasing throughout the visit. The final weighted desirability will always add up to 1 in total. This allows a random float between 0 and 1 to be selected to indicate the NPC's desire. The implementation of utility theory here means that the NPC is more likely to go to do something that they find more desirable, but at the same time encouraging randomness and emergent gameplay. The NPCs then enter a switch for the execution of the desire, which acts very similarly to a behavior tree. This then takes NPCs through a series of states in a finite state machine in order to achieve their desire. The way that this differs from a behavior tree is that the validation is done beforehand while calculating the desire in the first place, rather than exiting out as incomplete. At the end of the execution of each desire, it will then wander for 1 turn to perceive more artifacts before choosing a desire again. When an NPC finally decides to leave, they'll see if there's a path to the exit, and if there's not, they start to panic. While panicking, NPCs run to random positions very fast, and also panic other NPCs that perceive them while they're doing so. This emergent behavior will end as soon as an exit becomes available, and they can then leave. NPCs walk over a nav mesh generated by the inbuilt nav mesh function. The nav mesh uses a layer mask that only looks at solid walls and ignores the doorways, as well as taking into account objects but not their interaction points. It updates only when objects or walls are placed. Each NPC has its own custom version of the nav mesh agent pathfinding. It uses my own A* pathfinding to conclude that a destination is reachable, as I had problems with the inbuilt one returning true when a destination was absolutely not reachable. NPCs would just sit in corners, hallucinating that they were visiting things. My own A* implementation takes in a start and an endpoint and uses the museum grid to find out if it's a possible path. Then, once validated, it uses the inbuilt pathfinding to generate a sequence of corners, which are then stored as vector 3s in the NPC as their path. This saves heavily on cost compared to just using the inbuilt navmesh agent. Then the frame update within the move state will move the NPC towards their current destination along the path. If an NPC is in the move state and hasn't moved for a full turn, they have a 50% chance of moving backwards for 1 turn. Although this might not occur in the current version, as the NPCs have had their colliders removed so that the algorithms could be stress tested. As you can see, here are 2,000 NPCs in the museum at once. This is primarily because steering behaviors would be expensive to implement on every single NPC within the museum on a regular frame-by-frame basis. The combination of each NPC having their own, quote, personality as dictated by their interests, the ability to be influenced by other NPCs, and the random choice that they make each turn provides a lot of emergent behaviors.